This is 2.4 Algebra 1, page 88 in your book. So you think I have my board ready to go before I started these. Oop, let's see if it's going to work. It's going to be temperamental on me here. Okay, I said page 88 in your book, and the vocabulary, the only vocabulary, at least it's not the only thing probably key, but the vocabulary says multiplicative identity, and that is at the top of page 87. It says they talk about an activity that you do, but actually it is the identity is one of the properties in the key concept box over on page 89. So if you want to look over there, there is right underneath the key concept box says the identity property states that the product of a number 1, a and 1 is a. The number 1 is called the multiplicative identity. So 1 times a equals a. 1 times anything x equals x. 1 times 2 equals 2. 1 times 3 equals 3. And I kind of look at it that 1 is like a full-length mirror. A looks into the mirror and sees itself. X is the mirror, looks into the mirror and sees itself. So the identity, it sees its identity. That's how I remember it. That's the multiplicative identity. And it on page 89 is that if you want to see, have a better thing to write it out if you want. But that's the identity. Actually, it's the number 1. Anytime you multiply a number by 1, you get that number, and that's the identity. All right, let's go on. The next thing, we're going to talk about multiplying real numbers, and there is a key concept box, and I wish the key concept box were in the if I can say it right, or in the on the PowerPoint, so wouldn't have to write them. But the key concept says the sign of a product. There's words. The product of two real numbers and the same sign is positive. So I'm not going to write the whole thing, but whenever you take the product of two numbers with the same sign, it is positive. So an example would be 3 times 4 equals 12, or -6 times -3. Remember, parentheses means to times. That's also positive, positive 18. And so when the signs are the same and you're multiplying, the answer is positive. That looks like a minus. That's supposed to be like a dot for multiplying. Now here's the second part of the key concept box. It's the product of two numbers with different signs. The answer is negative. So that would be something like the example 2 times -5 equals -10. A positive one and a negative, that means different signs. And something like -7 times 2 would be -14. Alright, so there's our key concept box. Now I'm going to stay on this page for a second, and I wouldn't mind if you wrote this in your notes also. Basically the rules break down into this. If the signs are the same, the answer is going to be positive. If the signs are different, the answers are going to be negative. That's, in a bottom line, in a nutshell, that's the rules for multiplying integers. Well, another way to remember it, and I actually ran into somebody this weekend that said, I remember the story you told us about multiplying and how it's helped them. And this is a former student who's now in college. Said, I remember some story about cowboys, and it was this story right here about the good guys and the bad guys. So here's a way to remember the rules that relates it to a story. I'm going to write situations. You have good guys. You have good guys in the Old West, you know, let's think about an Old West kind of story. You have good guys, and always in the Old West, the good guys were positive. Those were the guys that kept the town running nice, everybody's happy. That's the good, the positive. We also had bad guys in our town, and bad guys, you know, they did nothing but create havoc, and it was nutty around, so they caused trouble all the time, so they were negative. Now back in the Old West, when we're trying to get your town, when they're trying to get their town established, there were, you know, you wanted people to come to your town. You wanted your town to grow. You wanted people to come in there, spend money, have a great time, you know, go to all the stores. So coming to town in the Old West, and in any situation, is a good thing, okay? The leaving town is a negative thing. You know, we don't want people to leave our town. If people leave our town, then they don't spend their money there anymore. So if we take and we put these together, we will have the rules for multiplying. So let's first talk about this. If we have good guys, which is a positive thing, coming to town, which is a positive thing, think about that statement. Do we want the good guys to come to our town? Absolutely. So those two positives make a positive. Okay, so there's a way to remember the signs are the same, it's positive. Now let's do another signs are the same. What about bad guys, which is a negative thing, leaving town, which is a negative thing when it's alone, but when we put it together, we listen to the statement, bad guys leaving town. Hey, that's a good thing. We want the bad guys to leave town, so that's a positive thing. So we have bad guys leaving town, two negatives make a positive, and there is the two statements that support that rule right there. Okay, signs are the same, it's positive. Now let's do the others. How about good guys, which is positive, leaving town, which is negative. And we say, hey, do we want the good guys to leave town? No, we don't. So that's a negative situation. And what about bad guys, which is a negative thing, coming to town, which is a positive thing in and of itself, but when we put it together, bad guys coming to town, you bad guys stay away from our town, so that's a negative thing. So then that would support this rule right there. So that's just the good guys, bad guys. All you got to do, you know, if you're stuck, you think about the good guys, bad guys little story going on right there. Okay, so let's take a look at some examples. Here, I gotta erase my stuff here. Hold on. So here we go. Find the product. Remember, a lot of times we get tripped up on vocabulary. Product means is the word for multiplying, so sometimes we forget that. So A, -3 times 6, and when I multiply, especially with integers, I do it in a two-part thing. I multiply the numbers, which is 18, and then I look at the signs. The signs are different, so it's negative. And I always do it as a two-step process. And you can sometimes you can do the sign first, and then the number second. It doesn't matter the order you do it in. And so they put -18 also. So this one, when you have three numbers, there's a couple of ways. Remember, multiplying, you can multiply in any order. So I could multiply these first two negatives together first, then times 2, or you could just go in order. I'll do it both ways, and you guys can see we'll come up with the same answer. Let's just multiply this -5 times -4, which is 5 times 4 is 20. Two negatives make a positive. So then 20 times 2 would be 40. Or you could go 2 times -5, which would be -10, times -4, and two negatives make a positive, and 4 times 10 is 40. So there's a couple of ways that you can look at that there. All right, and they're going in order. And again, you don't have to go in order. You can multiply in any order you'd like. And you could look at that to begin with and go, hey, there's two negatives. And you know two negatives make a positive, so then you know the whole answer is positive. So there's more than one way to look at those problems. Let me get rid of that, what I did right here with my little eraser. All right, so we go with this one now. First, let's just do the signs like I was saying. There's 1, 2, 3. So these two negatives would make a positive, and this would make it negative again. So that brings me to something that would be a little shortcut to remember, that an even number of negatives, this is only when you're multiplying, are going to be positive. They're going to cancel each other out. An odd number of negatives will end up negative. And so check, let's just look. These two would be positive because a negative times a negative make a positive. Then that would be positive. Positive times a negative would be back to negative. So we can look, we can do it a couple of ways. Let's just multiply in order. 1/2 times 4. Remember, instead of saying times, say the word of. Half of 4 is 2, and 2 times 3 is 6. And then we determined there's an odd number of negatives, so the answer is -6. And there's -6. Okay, so let's do some here. -2 times -7 is, 2 times 7 is 14. Two negatives make a positive. Done. Again, first off, I recognize this is a half, so I'm not going to freak out about that. I'm going to sneeze. Excuse me. Sorry about that. So the same thing we just talked about. 3 negatives. 1, 2, 3. So that's going to be negative because that's an odd number of negatives. Half of 4 is 2, and 2 times 9 is 18. So let's see what they came up with. Yep, -18, same thing. Okay, so 4/3. Let's first look through here and deal with the negatives. We have a positive and a negative and a positive. There's an odd number of negatives, so the answer is going to be negative. Now, remember, let's do a quick lesson on multiplying fractions. If you look here and I make this be when you multiply fractions, you have top times top, bottom times bottom. If I just forget about the 7 right now, let's just multiply these. And we've already dealt with the signs, so we don't have to worry about the signs. Well, when we look at canceling, those 3's cancel out because they're opposite of each other. So 4/3 times -3 is 4. And it's actually -4. Then -4 times 7 would be 28. So -28. Let's see what they come up with. Yep. So example number 2, and boy, there's a big table right here, and I know it's kind of a pain, but you can just stop. If you would stop the video, and I would, you can write down the key concepts right here. Go ahead and look. I'm just going to read through them and write them real quick, and then I want you to stop this and finish it off. You have the commutative property, which means you can switch the order. Like, 2 times 3 is the same as 3 times 2. You have the associative property, which tells you that, like this, 2 times 3 times 4, you can multiply 2 times 3 first, or you can multiply 4 times 3 first. And I always remember that as you can associate with different people, so the numbers are like people, so you associate, the parentheses have you associating with them. The identity property, which is what was in our, means you take it anything times 1. We have the property of 0, which basically says anything times 0 is 0. And then we have the property of -1. Okay, the product of a number and -1 is its opposite. Okay, so you can do a better job of writing down the stuff from the table, so you guys know. I think one of the best ways to learn things and remember things is to write them down. So take some time right now and write down these properties. These are on page 89. Stop the video right now and get that done. And I'm going to be looking for some really nice key concept blocks in your notes then. Alright, so we go to example number 2, and it's identity properties of multiplication. So here's this, we're supposed to say what is illustrated here, and I see the parentheses have been moved around, and you can even look up page 8, refer back to those. Which one shows the parentheses being moved around? The associative property. This is the property of 0. Anything times 0 is 0. This is the commutative property because we switched the order. -6 times y equals y times -6. This is the identity, or no, not identity, the property of -1, which is telling you anytime you multiply a number times -1, the answer is its opposite. Check that out with 9. What's the opposite of 9? -9. So that's what that's telling us to do. This is the identity property. Any number times 1 is that number itself. And then the guided practice then for example 2 has us doing some more of those. So identity property, identify the property as illustrated. So on this one, this is going to be the property of -1. Oh, I always write right on it, don't I? Look at that. This is the commutative property. That's the associative property. I won't write them. I'll let the PowerPoint do it. You guys are writing them. This is the property of 0. This is the commutative property again, right? They're switching the order. And number 9. I don't think that's right. -13 times -1 is not negative. I think it's supposed to say 13 right there. So I'll fix that. So -13 times -1, the opposite of -13, so that's that property of -1 is 13. Okay, example number 3, it says find the product of -4x times 0.25 and justify your steps. Identify the properties as you use them. It says sometimes when we can move things around, there's a reason why we can move things around and multiply things first. The first thing I see here is 0.25 is like quarters, and then I see a 4 right here, and I know 4 quarters makes $1. So right then I am going to use the commutative property to take -4 times 0.25 first. Okay, because remember I can multiply in any order right there. So I'm going to do that first. And then that comes out to be 1, actually -1. And the x, there's nothing, we don't know what x is, so it just stays like that. And the answer then would be -1x. And there's probably other properties, but let's see how they do it. They do the here, let me erase what I did. So they switch the order of it around. Oh, I see what they did. Then by taking 0.25 times -4, they did the associative property. And then -1 times x then would be -x. That makes sense to me now. Sure enough. So let's check out example number 4. Solving a multi-step problem. In 1900, the elevation of Mono Lake in California was about 6,116 feet. From 1900 to 1950, the average rate of elevation was about -0.12 feet per year, meaning it went down 0.12 feet per year. From 1950 to 2000, the average rate of change was about 0.526 feet per year. Approximate the elevation in the year 2000. So when we approximate the elevation, what we're doing is we're just going to use what information is given to us. And it said from I have to read it again, good problem solving says we want to read it again and see how many years, average rate of change. approximate the elevation. So from 1950 to, we got, I think there's two parts here. We got to tell how far it went down. And my pen, how far it went down from 1900 to 1950, and then how far down from 19, because there were two different numbers there. This was, so 1900 to 1950 is 50 years. So for 50 years, it went down negative 0.12 every year for 50 years. So we're going to multiply that. Plus the next 50 years, it went down, I should have used parentheses, down negative 0.526. So then we'll multiply that. So when I take 50 times, and that'll tell us how far it went down total. So 50 times negative 12 is, my pen, is negative 6, plus this one is negative 6.3, and I definitely think I would use a calculator to multiply those, for a total of negative 32.3. That's how far it went down, and it was at 6,416 feet, and it went down 32.3. I think I'm doing this, whoops, that's subtraction, sorry, a little different than what the book's doing, but let's just see if we come up with the same answer. I always say that's the good thing about math, is there's more than one ways to do things, and sometimes that's the bad thing about math, is there's more than one way to do things. So I'm going to say 6383.7 feet, and I think that's what your book says. So writing the verbal model, I don't always do that. They did, there's them taking the negative 12 times 50, which went down by negative 6, and they kind of subtracted as they went. That's what it was after 1950. I go to the next one. And then that's the same answer we got. Alright. Alright, find the product, justify your steps. I think here I would think of this as 3/10 times 5 times y. So instead of multiplying the 5 and the y first, I'm going to move these. So I'm going to use the associative property to move those. I'm going to put 5 over 1, 5, and that cancels. So I'm going to have 3/2 times y. And that's just, you can leave it. I believe you can leave it like that, 3.5 y, half y. Okay. See how they do it. They did the same thing. And then you just multiply. Okay, check the next one. I'm going to multiply. I think I'll just do these first. I'll move these two. I'm going to multiply these two first, which would be the commutative property when you switch the order, and it's also the property of negative 1. So negative 1 times negative x is positive x, times 0.8 is just 0.8x. They did the same thing, maybe a little differently, but you know what? We came up with the same answer. Check it out. 0.8x. Okay, number 12. Last one in this. I don't know what I would do on this one. I would probably, because I don't know if that's a property or not, but I think what I would do is just switch them around. I think I would take 6 times, and think of this as 50 cents, or half of 6 is 3, positive 3, then times negative y is negative 3y. Because we don't know what y is, so we just carry it along with it as a multiplication problem. And they pretty much, if you look at it, did the same thing. approximate the elevation of Mono Lake in 1925 and in 1965. Wait, I guess we got to go back. Let me go back, if it will let me. I don't remember the... Let's go back to that. Sorry, it's kind of weird, isn't it? It's taken off all the things that I wrote. Sorry. Okay, there's where I want to be. Wait, I'll keep going back. Sorry. Here we go. 1925. So from 1900 to 1950, remember we got -6. So 1925 would be half of that, which would be -3. So we'd take off 6416 minus 3 would be, it'd be at 6413 in 1925. And halfway between, so wait, 65 is another 15 years. So I would do 0.526 times 15, which I would use a calculator, and I don't have one with me right now, and then add that to what it was after 1950. That's kind of a mean little problem there, I think. Let me find that again. Hold on. Let me go through this. Boom, 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 boom. Look at how fast I'm writing. We had that one. I remember seeing that one. This one would have taken, this one here would have taken just a little bit of multiplying that I didn't do. So you guys can multiply that out. Use a calculator to multiply that, and it'll make it a lot easier. So remember the good guys, bad guys. Remember all those properties, and get all those notes down. And I think that's it. We'll see you next time.